Okay, so question 13, if you get asked to put it in this form, you're being asked to complete the square, which means you're always going to end up with something inside a set of brackets and it's going to be squared. Now, it's always going to be half of your b value. In this case, b, or the number in front of x, is 6. If you remember from when we do the a, c and b method, or the quadratic formula, in this case a is 1 and c is minus 7. But half of your b value, in this case plus 6, so half of that is plus 3, will always go in here. But if we think about x plus 3 squared, that actually gives us x squared plus 6x plus 9. So if I want this to be the same as x squared plus 6x, I need to take 9 from both sides. So this is equal to x squared plus 6x. So if I put that in, that's now x squared plus 6x minus 7. And if I put that together, I've got x plus 3 squared minus 16. You can think of it, the number that goes in here will always be half of your b value, and then we compensate by always subtracting the square of this number. So because 3 squared is 9, we do subtract 9, and then whatever the c value was before just goes on the end as well. And if I combine them, I'm left with x plus 3 squared minus 16. Okay, question 14. Cone A and cone B are mathematically similar. Now, it tells you that the ratio of the volume of cone A to the volume of cone B is 27 over 8. We can think of this as being a volume scale factor of 8 over 27. Now if that is our volume scale factor, you can also have area scale factors and length scale factors. Now the general rule, if you have a length scale factor, which is a scale factor between two lengths, if you square that, you get the area scale factor, and if you cube that, you get the volume scale factor. So going the other way, to get the length scale factor here, if I cube root 8 over 27, I can just cube root the top and cube root the bottom. So to get the area scale factor now, if I square my length scale factor, which is what I mentioned up here, that gives me an area scale factor of 4 over 9. If that's my area scale factor, if the surface area of cone A is 297, if I times that by my area scale factor, because it mentions area, surface area, so we're using the area scale factor, that should give me, sorry I'm a little bit off screen there, that should give me, using the calculator, so 297 times by 4 over 9, that gives me the 132, which is what the question says it should come out as. And then because it kind of shows you what you're working towards, you can now say surface area of cone B, and because you were given it, we can write as, there we go, catch up a bit because I've been doing a bit of writing off screen, as required. Okay, just be sensible when you do this, because if you were going the other way, if you were going from 132 to 297, I mean this is your final answer now, but if you were going from 132 to 297, your scale factor would be the same for areas, it would just be the other way around. So if I did 132 times by 9 over 4, that would give me the 297 that I started off with. So when you're using a scale factor, just make sure at the end, have you got it the right way around? If you're intending to end up with the surface area of the smaller shape, make sure it actually is smaller. And if you're going from an area to like the area of a bigger shape where you wanted your answer to be bigger, you'd have to make sure that this was the right way around it. In that situation you might have 9 over 4. But in this case, started off with a volume scale factor, which I've got from the ratio. I've cube rooted it to get my length scale factor, and then by squaring it again I've got an area scale factor, and that's what allows me to switch between areas. So this is what we started off with, and we can use that to work out the 132. And the final answer looks something like that.